What's going on, everybody? Got another video here for you. This is derivatives of the inverse trig functions. So it's not difficult to do. You just got to memorize the formulas. If you memorize the formulas, you can work them. I won't read through all of them, but we'll look at a couple of them here. The derivative of inverse sine u with respect to x. U is like a function in terms of x. It could be like 2x or x squared plus 1 or whatever it is. It's some function in terms of x. So the derivative of inverse sine u is 1 over the square root of 1 minus u squared times this right here, times the derivative of what you're taking the inverse sine of. So it's basically it's this formula right here times the derivative of whatever you're taking the inverse sine of. And then look, inverse cosine of u, the derivative. Look, you see it's the same as inverse sine except it has a negative and then times the derivative of what you're taking the inverse cosine of. And then tangent or inverse tangent is 1 over 1 plus u squared times the derivative of what you're taking the inverse tangent of. So, as far as memorizing them, look, inverse sine, inverse cosine, you can see they're similar. Now look at this, inverse tangent and inverse cotangent, they're similar. The inverse cotangent just has a negative in front. And then you can see inverse cosecant and inverse secant, they're similar. All right. And just remember, whenever you do the derivative, then it's always times the derivative of whatever u is, whatever you're taking the inverse trig function of. All right, so let's get started on some examples. We got some examples where we just find the derivative, and then we got a couple of application problems at the end. All right, so our first example here, the derivative of inverse sine 4x. So what I would do is go back up here, write all these formulas down so you'll have them on a piece of paper while you're watching the video so you can follow along. All right. So just pause the video and do that. All right. So we've got y prime is equal to, so the inverse sine is 1 over the square root of 1 minus u squared. So that's minus 4x squared, all right, times the derivative of what you're taking the inverse sine of. So what's the derivative of 4x? So that's times 4. And so we get y prime is 1 over the square root of 1 minus 16x squared. Well, and let's just do the 4 times 1 and put the 4 in the numerator. And so this is your answer. You see how easy it is? It's not bad at all. All right, so let's look at this one. We can't keep all the problems easy. We got to have a few that are a little difficult. All right, so we've got the derivative here. So what in the world do we do with this one? Well, this right here, we've got product rule, don't we? You see that? We've got x squared plus 1, that's the one function, and then inverse tan x, that's another function, and then we've got minus x. So the derivative is, so remember the product rule, that's the derivative of the first function, which is 2x, times the second function, inverse tan x, plus the derivative of the second function. So what's the derivative of the second function? That's 1 over 1 plus x squared. Looking at your paper where you wrote the formulas down, that's the derivative inverse tan, times the derivative of what you're taking the inverse tan of. So the derivative of x is 1, so that's times 1. We won't write it down. And then times the second function. And so that's times x squared plus 1. All right. And then minus the derivative of x is 1. All right, so let's just recap what we did here. So we've got the derivative of the first function times the second function plus the derivative of the second function times the first function. That's for this part right here, product rule. And then minus the derivative of x. The derivative of x is 1. All right, so now let's simplify it. So we get y prime is, so that's going to be 2x times inverse tan of x plus, oh, look at that, x squared plus 1 plus x squared, that cancels out. That's 1 minus 1. So we get y prime is 2x times inverse tan x. And there is our answer. All right. See, it's not bad. Not bad at all. All right, so how about this one? So we got product rule. We've got this function, and we've got this function. This is our first function, and this is our second function. So let's take the derivative. So we get y prime is the derivative of the first function, which is 1, times the second function, inverse tan 2x squared. All right, plus the derivative of the second function. Now look at this. For this one, we have to do what? We have to use the chain rule, right? So to do the chain rule, that is going to be 2 times inverse tan 2x, right? The 2 comes down, subtract 1 from the exponent, so that's going to all be to the first power, times the derivative of what's inside the parentheses here. So what's the derivative of inverse tan 2x? That's going to be times 1 over 1 plus u squared. So that's 2x squared times the derivative of what you're taking the inverse tangent of, times 2. Okay, so all of this right here is the derivative of the second function. The 2 comes down, subtract 1 from the exponent, times the derivative of what's inside the parentheses, which is 1 over 1 plus u squared, u is 2x in this case, times the derivative of what we're taking the inverse tangent of, which is 2, and then times the first function. Okay, now comes the fun part. Now we need to see about simplifying this thing. So let's see, we've got y prime is inverse tan 2x squared plus, so that's going to be 2 times x, so that's going to be 4x inverse tan 2x over 1 plus 4x squared when we square that. So now let's factor out an inverse tangent 2x. And that'll leave us with inverse tan 2x plus 4x over 1 plus 4x squared. And that should be our answer. I believe it is. And so there's your answer. So that one got a little messier than the other ones, but we're still good. We still understand how to do all this stuff. Oh goodness, let's look at this one. Let's see what we got here. All right, so let's take the derivative of this thing. So we've got y prime. All right, so you can see here we've got product rule on this term. So this is your first function. This is your second function. So the product rule says the derivative of the first function, which is 1, times the second function. Okay, derivative of the first times the second, plus the derivative of the second. So what's the derivative of inverse sine? Well, that's going to be 1 over the square root of 1 minus u squared. U is 2x in this case, so 2x squared, times the derivative of what we're taking the inverse sine of, so times 2. So this is the derivative of the second function times the first function times the first function. Plus, now we have to take the derivative of this term. So this is going to be 1/2. That's just like a constant, and that's a constant in front of your square root. Now, I know a lot of you watching this might have learned, take this 1 minus 4x squared, the square root of that, and change that to the 1/2 power, and then take the derivative. I'm going to show you a little tip right here on finding the derivative of a square root. There's a shortcut. So whenever you're taking the derivative of a square root, it's 2 times whatever the square root is. Okay? 2 times whatever that is. And then in the numerator, you put the derivative of what's underneath the square root. So what's the derivative of 1 minus 4x squared? Negative 8x. All right. And now we need to clean this up some. So that's inverse sine 2x plus, and then that's going to be, what is that, 4x? No, not 4x. Where am I getting 4x from? 2x over the square root of 1 minus 4x squared. And that is going to be minus, let's see, that cancels with that. That goes in that 4 and then 2. So is that going to be minus 2x over the square root of 1 minus 4x squared? Well, look how that worked out. That goes to 0 right there. And so we get y prime is inverse sine 2x. Who would have thought that? So that was nice how that canceled out. That made it a little easier on us, didn't it? I mean, that wouldn't have been tough. Had a common denominator. We could have combined those easy, even if they wouldn't have canceled out to 0. All right, so let's take a look at this one. All right, so here's one of the applications. We've got find the slope of a tangent line to the curve y equals inverse tangent x over x squared plus 1, where x is equal to 3.6. All right, so slope of the tangent line, that means we have to take the derivative of y and then plug 3.6 into the derivative, and that'll give us the slope of the tangent line. All right, so for this one, we have to use the quotient rule. So we've got y prime is, okay, so the quotient rule is the derivative of the numerator, which that's 1 over 1 plus x squared, times the denominator, right? Minus the derivative of the denominator times the numerator. And this is all over the denominator squared. Well, they're making these problems easy on us, aren't they? All right, so let's see. Well, if you look at this, that cancels out. And so we're left with y prime is equal to 1 minus 2x times inverse tan x over x squared plus 1 squared. And so there's your derivative. Now we just have to Now we just have to plug in the 3.6. And so we get y prime of 3.6 is equal to 1 minus 2 times 3.6 times the inverse tan of 3.6 over 3.6 squared plus 1 squared. And this is not one you're going to be able to do in your head. You're going to have to punch that into your calculator. And when you do that, you're going to get negative 0.0429. Now, pause the video, plug that into your calculator and see what you get. If you don't get that answer, it's one of two things. You type something wrong in your calculator, or you have your calculator in degrees. You have to make sure that your calculator is in radian mode. Okay? All right. Last problem here. All right, let's see what we've got here. So it says a 20 Newton force acts on a sine as shown in the figure. Express the angle theta as a function of the x component, f of x, of the force, and then find the expression for the instantaneous rate of change of theta with respect to f sub x. All right, so we've got the sine here, and we've got these forces here. We've got f sub y, f sub x, and then here's that 20 Newton force, and then it acts on that angle theta. So what we need to do is we need to figure out, well, we need to set up what cosine is. Or, well, yeah, it'll be cosine because, see, if we drop this down here, we got a right triangle, and this is the side adjacent. This is the hypotenuse, so we know that's going to be cosine. So we know cosine theta is equal to adjacent over hypotenuse, which that's 20. Force of that one is 20 newtons. And so this, let's see, what does this tell us? This tells us that theta is equal to inverse cosine f sub x over 20. Okay, because what did they say? They said express the angle theta as a function of the x component f sub x of the force, and then find the expression. So that's this part right here. Okay, and now we want to find the instantaneous rate of change of theta with respect to f sub x. And so we have d theta with respect to f sub x. So this is our variable here. So we're taking the derivative of inverse cosine. So what's the derivative of inverse cosine? And I tell you what I think I'm going to do here is I'm going to write this again. Let's write this as inverse cosine, just so I don't have to look at that fraction. You see that 1 over 20? If you put 1 divided by 20 in your calculator, that's the same thing as 0.05 f sub x. Not really that much of a difference, but just looks a little easier, don't it? So this is going to be negative 1 over the square root of 1 minus u squared, which is this, 0.05 f sub x squared, all right, times the derivative of what you're taking the inverse cosine of. So the derivative of this is times 0.05. And so we get negative 0.05 over the square root of 1 minus, let's see, what is 0.05 squared? That's 0.0025 f sub x squared. And there's your There's your instantaneous rate of change of theta with respect to f sub x. So that's the inverse trig functions, the derivatives. Now I know I didn't do any examples with cosecant, secant, or cotangent, but they're done just like these. You just use the formulas. That's all you're doing. Okay? Students will struggle with this sometimes, finding these derivatives, and the only reason they struggle with them is because they don't have the formulas memorized. You've got to memorize them. If you don't memorize the formulas, you're not going to be able to find the derivatives of these things. It's just like with the trig functions. Do you know how to find the derivative of sine, cosine, and tangent? Of course you do, because you got them memorized. The derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared. Okay, and then you know the derivatives of cosecant, secant, and cotangent. All right? So memorize these things, and you'll be able to do them. They're not difficult to do. It's just remember, just a recap. Okay? It's the derivative of inverse sine u is this, and then you have to multiply it times the derivative of whatever you're taking the inverse sine of. And that's how it works for every one of them. All right? So I hope this video helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I'll see y'all in the next one. Later.